Today we're going to talk about solving a system of inequalities by graphing. In one of my previous videos, I talked about graphing inequalities, so this is going to help us out a lot for doing solving a system by graphing. So one of the key things that we need to make sure we pay attention to when graphing, one of the easiest ways to graph, in my opinion, is through slope-intercept form. Slope-intercept form is y equals mx plus b. A couple of things to make note. The slope, which is always m, if positive, we're always going to go up and to the right. And if negative, we're going to go down and to the right. And so depending on the slope, whether it's positive or negative, we're either going to go up and to the right or down and to the right. Now, the other thing that we're going to need is that y-intercept. And that y-intercept, that is where we always start, okay? And remember, the y-intercept is always located on the y-axis. So our goal today would be to make sure we get all our inequalities in slope-intercept form. Once they're in slope-intercept form, we'll be able to use this to guide us on how to graph those inequalities. Now, there are a couple of key things that we need to remember. First thing is, when rearranging inequalities, remember to always flip the sign whenever you divide or multiply both sides by a negative. Okay, so when we're adjusting some of those inequalities, we do have to be careful of that one thing, is that when we're either dividing or multiplying both sides by a negative, then we are going to have to flip the sign. A couple of other things that we learned last time were our line. And our line could be one of two ways. It could be dashed, and that's if it's greater than or less than. Remember that the dashed line implies that any point on that line is not a solution. And then it could be solid. And remember, that's if it's equal to. Notice greater than or equal to or less than or equal to. That implies that every line or every point on the line is actually a solution. So that was one of the first things that we had to remember. The last thing is that there was always some shading. And you either shade above if it's greater than or below if it's less than. Now, do remember I did use a test point in the previous video to make sure I showed you. Here, we'll probably focus a little bit more on the greater than or less than to determine how to shade. Now, for today's stuff, since we are going to be graphing two inequalities on the same graph, it would be best to always make sure when you're doing this that you use at least two different colors. Because when we're doing two different colors, you'll be able to see the final solution a lot better. And so I'll show you that in this first example, and then you can try it out in the next. So here we're given a system of inequalities, and we're asked to graph and solve the system by graphing. So what I'm going to do is I'm going to take the first inequality. I do notice it is in slope-intercept form. So just a couple of things from that first one. I notice that the slope is equal to 1/2. And I notice that the y-intercept for that first one is a positive 2. And so starting by graphing the first one, remember, we always start with the y-intercept. So in this particular case, we're going to start at positive 2. So at positive 2 on my y-axis, that is where I start. The slope, remember, when the slope is positive, we are going to go up and to the right. So from my starting point, I'm going to go up 1 and right 2. And again, remember, we can take this as far as we need to go. And it's good to get a full or a range of the graph all the way across. Now, do remember, you can do the complete opposite. That would be down 1 and left 2. That way we get that full view. Now, next was to determine if it's going to be a solid or dashed line. Now, because it is equal to, remember, that implies it's going to be a solid line. So because it's equal to, we can go ahead and draw our solid line. And then lastly, we have to determine the shading for that first one. It is greater than, so that means everything above the graph. So I'm going to go ahead and shade everything above the graph. And now we're in a sense done graphing the first inequality. Now do remember, this is a system. So obviously there's more than one thing we're going to be graphing. So let's go ahead and graph the next one. So this other one, based on that, I see that it has a slope of -3/2, and it has a y-intercept of -2. So again, we always start with the y-intercept. So at -2, that's where I'm going to start, right there on the y-axis. And here, since the slope is negative, remember that's down and to the right. So from my starting point, I'm going to go down 3, 1, 2, 3, and right 2. And down 3, 1, 2, 3, and right 2. And remember, you can do the complete opposite. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And once we get our full array, then we go ahead and decide, is this going to be a solid or dashed line? Think to yourself for a second, but again, because it is not equal to, that means it must be a dashed line, because no point on that line is going to be part of our solution set. So we go ahead and set up our dashed line. And then lastly, we do our shading for that line. Notice that it's less than, which means below the line. So this would be the below the line. And so I start shading below the line, below my blue line that we just drew. Now, when solving a system of inequalities, what's really our answer? Because, I mean, right now I see a ton of different shading areas and so forth. The solution to a system of inequalities is where both shaded regions overlap. This is where every single point is a shared point for both of the inequalities. So truly, this section right here, where our two shadings overlap, that is our solution area. Okay, so that means any point in this double shaded region, that is going to be a solution to our system of inequalities. Now again, a point in here, that's not going to work. It will work for one of the inequalities, but not the other, because this is only shading for one of them. Same idea with this one here. A point in here will work for one of the inequalities, but not both of them. So again, where the shadings overlap, that is the true solution area. Any point in this section where the two shades overlap, those are our solutions to the inequality. Now, just to be a little bit careful too, anything on this line would not be part of our solution, right? Because anywhere from here to here to here, this is all a whole dashed line. We could not pick that point right there. It would not be part of our solution. However, this point right here, the -4, 0, it actually would be a part of our solution because it is on the solid line and it is kind of count in this shaded region. Okay, so keep that in mind for that. So again, remembering our main area is where the shadings overlap. That is what we're looking for. That is the true and final solution area. Let's go ahead and try one of those on your own. So hopefully you kind of worked it out and you used two different colors. If you did, this is what it should have looked like. So in a sense, for the first one, you're starting at -3. You would have went up 2 and over 1. It would have been equal to, so we had a solid line there and shaded everything above. And so make sure you're checking every single part of this, right? Because every single part is what makes our graph and our work correct. So again, then I do the second one, starts at +2, you want to down and over, and then again equal to, so a solid line, and it's a greater than, so everything above. Now again, remember our final solution area is truly this area right here where both shadings overlap. Okay, so if you missed any part of that, kind of go back and think, where did I start with the wrong y-intercept? Did I do the slope incorrectly? Did I have a solid when I should have had? Did I have a dash when I should have had a solid line? So think about those things and maybe check your shading too, and try to figure out why you made any mistakes if you did. Now, there will be some that we do that, you're going to have one in slope intercept form and the other one might not be. So in this particular case, we kind of have that. I noticed that the first one is not in slope intercept form. And I know I like to graph using slope intercept form. So what I'm going to do is I'm going to take this first inequality, this x minus 2y is less than or equal to 4, and I'm going to rearrange it to get it in slope intercept form. So we'll go ahead and start rearranging using our inverse operations. We go ahead and subtract x to the other side. I get negative 2y is less than or equal to negative x plus 4. Again, trying to build this situation of slope-intercept form. I need to get rid of this negative 2, which is with the y, so we're going to go ahead and divide negative 2. Now, again, if we go back to our helpful reminders, when we divide by a negative, we do need to flip the sign. So it now becomes greater than or equal to, because we are dividing everything, both sides, by a negative. And so we get y is greater than or equal to a negative, and a negative make a positive, so that becomes 1/2 x. And 4 divided by negative 2 is a negative 2. And so now we've got it in slope-intercept form. From there, we can go ahead and graph. So I start, remember, always start with your y-intercept. So at negative 2, that's where we're going to start. The slope is 1/2, which means up and to the right, being that it is positive. So we're going to go up 1 and right 2, up 1 and right 2, up 1 and right 2, and we can go as far as we need. Again, remembering you can also go the complete opposite way, so we get the full range of the graph. Once I have my point, then I have to decide, is it going to be a solid line or a dashed line? Well, because it's equal to, that implies a solid line. So we'll go ahead and draw our solid line through all these points. And this one says greater than, which means we are shading above. And remember, you're using that final version to decide that. And so it is greater than, and so we're shading everything above that region. So once we've got the first one graphed, every part of it correct, then we can go ahead and look at the second one. Now the second one is, one of our special cases. And again, when there's no y, if you kind of forget with this one, this x is less than 2. When there's no y, this is that special case of our vertical line. Okay, our vertical line. So this is going to be a vertical line. Remember, when there's no x, that's that horizontal line. And a vertical line always goes straight up and straight down. So at x is 2, that's where x is equal to 2. Again, it's a special case. This is some of the only times that we're not going to be on the y-axis when we start. And so this is our special case. Now, again, I do have to determine, because it is going to be a line straight up and straight down, is this line going to be solid or dashed? Well, because it's not equal to, that means it's going to be a dashed line. So we go ahead and draw a dashed line. For that. And then lastly, we determine which way to shade. Now it is less than, which would mean below, but I don't really have a below here. So that might throw you off. But again, think of the x values. It says x is less than 2. So when I look at the x values, well, which ones are less than 2? 3, 4, 5, 6, 7, 8? Or 1, 0, negative 1, negative 2, negative 3? Obviously, the values on the left of 2 would be less than 2. And so that's the values that we shade. And so we go ahead and shade our graph to the left of our line in this particular special case. And so I shaded everything to the left of the line. And again, where is our final solution? Our final solution is where the two shades overlap. Okay, anywhere in this double shaded region, that is where the two solutions overlap. And do remember, in this particular case, these points would work because they are on the solid line. These points right here would not work because they are not on a solid line. So just kind of keep that in mind for those for those lines and so forth, and how they work with our solutions. And you can always test it out by picking a point and plugging it in. And remember, the point must work for both of the inequalities, not just one, but both of them. Okay, so that's another way you can test to see if you have the correct solution area. All right. Let's go ahead and try one of those on your own. So again, given one where you have one in standard form and one in slope-intercept form, give it a shot. As you work through it, hopefully you rearrange the first one correctly. Do be careful in this rearranging. You should have flipped the sign. So if you forgot to flip the sign, you might have had your shading wrong here. So that's something to look for. Double check your work as you went through it and so forth to see that there's anything else that you might have been missing. And then again, making sure that your lines are the same, that they should both be solid, and that you shaded the correct areas. If not, try to make note and figure out where you might have messed up or where you just kind of went wrong, and again, think through that. Kind of do your problem solving. All right. Then we're going to have types of problems that we're going to get where neither of them are in slope-intercept form. So it's kind of doing the same process twice over. We just got to get it in slope-intercept form and graph. So let's take that first one. X minus 2y is greater than -4, and let's go ahead and rearrange it into slope-intercept form. So we move the x doing our inverse operation. We get -2y is greater than -x minus 4, again prepping for that slope-intercept form. I go ahead and divide by -2, and I'm recalling in my mind, oh, I'm dividing both sides by a negative. That means I must flip the sign. So I have to flip the sign in this particular case. And so I get 1/2 x plus 2. And so I'll start with the y-intercept, which again is going to be at +2. The slope is 1/2 and it's positive, so that's up and to the right. So we're going to go up 1 and right 2. You go as far as you need to go, remembering you can always go the complete opposite. Then we determine again if it's going to be a solid or dashed line. It is just less than, it is not equal to. So being that it is not equal to, we're going to have a dashed line. And then it is less than, we did have to flip it, and we are focusing on the very end version. And so less than would be below the graph. And we're just going to have to rinse and repeat, pretty much do the same thing for the other inequality. It's not in slope-intercept form yet, so we're going to have to take it and put it in slope-intercept form. So let's rearrange again. We have 2x plus y is greater than or equal to -3. That is the other equation. So we're going to go ahead and rearrange it. Go to move the 2x to the other side to prep for slope-intercept form. Nothing with the y this time, so that's perfect. It is in slope-intercept form now. So I'll start with my y-intercept, which is at -3. So at -3, that's where I start. My slope is -2. Remember, this can be written as a fraction, but that means down and to the right. So we're going to go down 2 and right 1, and down 2 and right 1. And we can do the complete opposite, up 2 and left 1. Again, determining whether it's going to be a solid or dashed line, because it is equal to. Equal to implies that solid line, that every point on that line could be part of our solution set. Said could be, not every single one will be. And then again, this one says greater than, so that means everything above the line. So we go ahead and shade everything above our line. And remember, the whole goal of this is to look for things that are in both the shaded region where both shadings overlap. Both shadings overlap. And so again, this is our solution area. And again, how you can always test that if you're not sure if you have the correct shaded region. And I'll show you this. I didn't do it with the other ones, but I'll do it with this one. So let's say I wanted to test that I did everything correct because this is the double shaded region. Well, I notice that 0, 0 is in this double shaded region. And so I'm going to test it. I want to make sure that this makes both inequalities true because remember, it has to make both of these true in order for it to truly be a solution. And so I'll test the first one. And in this case, you got to actually have to test both of them. So I take the first inequality, and I'm going to plug in for x and for y, 0 and 0. And again, it was in my double shaded area, so I'm just checking it out. I get 0 minus 2 times 0 is greater than negative 4. Well, 0 minus, 2 times 0 is also 0, so 0 minus 0 is still just 0. And I get 0 is greater than negative 4. And this is true. So it made the inequality true. Perfect. But again, in order to be a true solution area, it does have to work for both of the inequalities. So let me test the other inequality with the same test point. So I'm taking the 2x plus y is greater than or equal to negative 3. I'm plugging in 0 for both x and for y. Again, 0 plus 0 is going to be 0, and in this case, it also makes it true. So it made it true for both of my inequalities, so then I know I truly have the correct solution area. So this is how you can test if you're doing it right or not, right? If you finally get that final answer and you're like, am I really sure that this solution area is correct? We'll take a point anywhere in there. I always try to find an easy one, right? That's why I found 0, 0. But you could have used like 6, 0. You could have used this point. You could have used that point. You could have used this point. It doesn't matter which point you use. You just choose one and make sure it makes it true for both of the inequalities. If it only makes it true for one and not the other, then you did something wrong. Okay, then your solution area is incorrect. So either double check your work to make sure you did all your work right. And if all the work's right, then maybe you shaded incorrectly. So you have to double check that. All right, so let's go ahead and try one of those on your own. Hopefully you worked it out and rearranged both of the inequalities. Double check your rearrangements. Make sure you did the right steps. See if there's anything that you missed there. Again, when you're checking the graph, make sure you're checking for solid or dashed lines, making sure you're shaded the right way and so forth. If you're having troubles on that, make sure you just kind of look back at our little helpful reminders and so forth. Even in the previous video, we talked about using test points. You could have done that for each one separately to really help out in figuring that out. But double check your work, always making sure to see if you did all the correct steps. All right, and the very last type of problem that we're going to look at, just to kind of really make sure we hit the mark. This says, given the graph, state one solution to it. So again, just trying to remind you that any one of these, you have to really think about, and where is that true solution? So I want you to take a minute and see if you can pick one solution before I do. Now again, when I pick my solution, remember, you don't have to have the same one. So for example, for me, I see my double shaded areas right here, and I see that 0, 0 is in that double shaded area. So this would be one solution to it. Well, guess what? You didn't just have to have that point. You could have had the point 1, 0. You could have had the point negative 1, 0. This is actually on the solid line, and that would have worked. You could have had the point 2, 2. That's right there. So any point in this shaded area is a solution. Do remember on the dashed lines, those points aren't a part of it, right? So if I said 4, 0, which is, or sorry, 4, 2, which is this point right here, that would not be a solution because it's on the dashed line, and points on dashed lines are not part of our solution set. However, if I said the point 0, 2, which is this particular point right there, that is on the solid line. It is actually a part of our solution set. And so those ones would be a part of it. So any point in there, you didn't have to have the same one as me, but any point in this double shaded area is our solution. So kind of make sure that that's hitting home, that it's where the two shadings overlap. That is your true solution area. I hope this video was helpful. Again, make sure you rewatch it as many times as you need to, looking for those key things on when you're graphing, that you have the solid lines, the dashed lines, you're shading correctly, and you're rearranging correctly. If you're forgetting to flip the signs, kind of keep making note of that on your papers and so forth. But good luck, and I hope this helped.